Good morning, everybody. My name is Shagufa Khan, and my ID is H111-58254. And today I will be teaching chemistry for year 13 based on the topic periodic table. So to begin with, our topic is trends in the periodic table. So students, what comes in your mind when you hear about periodic table? Right, the questions which must be coming in your mind is why can't you change the periodic table, or why can't you change the numbers which are given on the periodic table, or maybe why can't you change the position of the elements, right? So the simple answer is that you cannot change the position or the number of the periodic tables because it has some importance and some trends in this. So that is what we will study in today's topic, the trends which are in our periodic table. And before I start off with the class, let me tell you what I'm expecting from this after end of this lesson is you should be able to explain atomic radii, ionization energy, and electron activity with respect to the trends on the periodic table. So this is the three trends which we'll be studying in this class, okay? Says periodic trend is a pattern of a change in the properties of elements in the periodic table with increasing atomic number. So it's just simply saying that from when you move from one side to other side of the table, you are looking at the atomic number with the increasing in the numbers of the atoms. And the important trends that would be studied include atomic radii, ionization energy, and electron activity. First one is atomic radii. And from the previous knowledge from the maths class, you know that radii comes from the word radius, right? Which describes the size of the particular subject. So in this, we are looking at the size of an atom. So atomic radius describes the size of an atom. There is a variation in the atomic radii across the period and down the group of the periodic table. So looking at the trend across the period, the trend is the atomic radii decreases across the period. Atoms become smaller moving from left to right of the periodic table. And the reason is that moving across the period, the effective nuclear charge increases as electrons are added to the same shell. And as the nuclear charge increases, electrons are pulled closer to the nucleus, therefore the radius decreases. So simply what happens is that as you move from left to right side of the periodic table, the electrons are added to the same shell. And increasing in electron causes the increase in the effective nuclear charge, right? It causes attraction between the nucleus and the valence electrons. So for that reason, the size of the atom gets smaller because of the attraction. And the trend down the group says the atomic radius increases down the group. Atoms become larger moving down the group of the periodic table. And the reason is that when you move down the group, the nuclear charge increases. However, more electrons are added and valence electrons become further away from the nucleus, creating a shielding effect. And this masks the effect of increased nuclear charge. Due to increased shielding effect, the effective nuclear charge decreases, therefore radius increases. So what happens here is that as you move from top of the periodic table to the bottom, at every new level, there is addition of a new shell. And that addition of a new shell causes the shielding effect, right? And for that reason, there is an increase in the size of the atom. Right, here's an example. It says across the period, if we look at this is boron, carbon, and nitrogen, right? Looking at the electron configuration, you can say this is boron, carbon, and nitrogen. If you look, the similarities that all of them, they have three shells. But the difference is that look, the valence shell, they have an extra electron. And that electron increases the effective nuclear charge. And that causes the shrinking effect, right? And then electron gets smaller because of the attraction. Down the group is hydrogen, lithium, and sodium, right? So moving from top, you have only one shell, valence shell. Lithium has two, sodium has one. So this is a new addition of a new shell, right? And this causes the shielding effect, and that's why the atoms get bigger when you move down the group. Let's talk about ionic radii. Simple as atomic radii, but in this we are talking about the ionic form, right? For example, you have Na is a normal neutral atom, but Na plus is an ionic atom. Okay, is an ionic. So ionic radius describes the size of an ion. So cations, these are positively charged ions and are always smaller than the atoms from which they are formed. As electrons are removed from an atom, the electron repulsion decreases. This allows the electrons to be pulled closer to the nucleus. And another reason for the decreased size of cation is that when electrons are removed, there are now fewer electrons to be pulled towards the nucleus by the same number of protons. And this results in stronger attraction, therefore size decreases. And anions, these are negatively charged ions, and these are always larger than the atoms from which they are formed. When electrons are added to an atom, there is an increase in the electron-electron repulsion. This causes the electrons to push apart and occupy a larger space, right? So that's the reason that the anions they increase when you move. This causes the electrons to push apart and occupy a larger spaces. Adding electrons also results in weaker nuclear pull, and as more electrons are now available with the same number of protons. This results in weaker attraction, therefore size increases. Right, here is a comparison of the ionic radius with respect to the neutral atom. So can you see for the cations, the neutral atom is actually larger than of the ionic, and for the anion, the neutral atom is actually smaller than the ionic atom. The third one is the ionization energy. It says ionization energy is the energy required to remove an electron from an atom in its gaseous state. And this reflects how tightly an electron is held by the nucleus. And the trend says it increases across the period. So similarly, just like the atomic radii and ionic radii, right? The trend increases across the period. And the reason is that when you move across the period, the effective nuclear charge increases. Therefore, electrons are strongly held by the nucleus. So it requires more energy to remove the electron. And the small size of the atom also results in electron being held tightly, right? Isn't it? When we talked about atomic radii, it says when you move from left to right, the atomic radii decreases. So same thing happens here. When you move from left to right of the period, the ionization increases because the electrons are the atoms get smaller, and therefore you require more energy to remove the electrons. Down the group, the trend is the ionization energy decreases down the group because even though the nuclear charge increases, electrons are added to the new energy level, right? And in addition, electrons are also more shielded, resulting in weak attraction. And because of the weak attraction, we do not require more energy to remove the electron from the valence shell. And the larger the size of the atom also results in lower ionization energy. An important note here, to remove electrons from shells, subshells or orbitals, which are fully or half-filled, require more energy as they are very stable. Right. Even though if you have a partially filled shell or a half-filled shell, you will require more energy to remove the electron from a halfly filled shell than of the partially. Right. So note that. The last one is electronegtivity. It is the measure of a strength of an atom's attraction for the shared pair of electrons, right? And the smaller the size of the atom, the more strongly these electrons are attracted to the nucleus. Small-sized atoms have high electronegtivity values. The trend is electronegtivity increases across the period, and the reason is when you move across the period, the effective nuclear charge increases. And since electrons are added to the same shell, as a result, the electrons are held strongly by the nucleus. The smaller size across the period is also a reason for higher electronegtivity. And as electrons of small size atoms are closer to nucleus, are held more strongly. So this is the reason why the electronegtivity increases when you move across the period. And the trend down the group, the electronegtivity decreases down the group. Reason is moving down the group, more shells are added, resulting in increase in atomic size. There is also an increase in shielding effect, and these factors mask the effect of slight increase in nuclear charge. Now you have an activity, so I want you to attempt this activity for your homework, and we will discuss this in our next class. Right? There are 5 questions, important questions. You should be able to answer these questions. And since we are running out of time, let's conclude our lesson. And to conclude, please note that we have covered the important trends in the periodic table, and you should be able to explain these trends, right, with a reason. And just a reminder, please go over the notes and attempt the activity questions, right? And below is also some of the readings and videos, right? I'm sure you'll not be disappointed watching these videos. Right? It has some important information about this class, okay? And even though the reading, right, it's just 2 pages, it's not wrong and contains very good information about our class. So far, any questions related to our class? No? Yes? Right? If not, then we'll finish off our class. And also, this is a periodic table which you can have. Right? This periodic table is also in your textbook, right? At the back of the textbook, right? It's present available there. So you can use that, or you can use this either, up to you. So if you do not have any questions, we'll wrap our class here. And until we meet again, please stay safe and take care, everyone.